Hello, everybody, and welcome to our SurrealDB stream number 3. Today, we are going to be focusing on SurrealQL with Misha, Toby, and Alex. But before we get started, we'll just wait for everyone to join us. So perhaps we can hear where you're watching from. We're obviously going out live to LinkedIn, YouTube, Twitch, and Twitter. So Puel, who said, "Oh, how come you're not on Twitch?" We are on Twitch at SurrealDB. So you can go and join us there as well. We look forward to hearing from you. So from Poland, hello. So just as we wait for a few more people to join, it's been a really busy week for us at Surreal. Some of you will have seen that Finn Bear, and yes, that's actually his real name, and it's amazing. So Finn joins the team. He's an avid Rust engineer and one of the largest contributors to the SurrealDB code base. We also have 2 of our international team visiting this week. Pratim, who will be giving a spotlight talk at our first SurrealDB social in our London HQ tomorrow, which is almost sold out if you want to get a ticket. And then Misha, who joins us from the Netherlands, who's here today. Oh, good evening. Hello, great to hear from you. Hello from Ukraine. Hi, Paul. So just a few reminders before we get started and dive into SurrealQL, which is what we're focusing on today. We have Farami, who is going to be moderating today to make sure everything runs smoothly. And we encourage you to leave comments and ask any questions during the stream. And then on that note, actually, today we're going to be trying something new. And after this stream, we are going to be hopping onto our Discord, so SurrealDB's Discord, for a live Q&A on their stages. So we really encourage you to join us there. Randy is going to be sharing the link to SurrealDB's server in the comments shortly. So if you're not a member of that, you can join it now and then join us later. Yay! I agree. Okay, fantastic. And hello, Osorio, and hello to Colombia. Okay, Toby, I think we are fully assembled. Let's dive in.
Excellent. Welcome everyone to I think it's our 4th stream. So yeah, welcome. Thank you for joining us. Today, I'm joined, as Lizzie said, by Misha and Alexander, and we're going to be looking at SurrealQL in a bit more depth, looking at the history, looking at why we chose to go with an SQL language, what are the benefits of SurrealQL over traditional SQL or other query languages that you see in other databases. And we'll also be talking about a bit of the kind of plans of where we're going with SurrealQL, what we've got coming, without giving too much away. Obviously, we never want to give too much away. So I presume everyone on this stream already has heard of SurrealQL, being the query language that that you use to query SurrealDB. Very similar to to traditional SQL, but with some differences. And I guess that's always a contentious issue. You know, some people say, why didn't you use traditional ANSI SQL standard? Yeah, look, today we're gonna go over some of those decisions, the design decisions that we used, and to kind of kick it all off, I'll bring up Alexander, who Alexander is our data evangelist, and he loves data, he breathes data, and he's going to talk a little bit about kind of the history of SQL and bring that forward to SurrealQL and SurrealDB today.
Yeah, thank you very much, Toby. The history of SQL is actually very, very fascinating, and it goes back to the earliest kind of databases, where first we had kind of like network databases that were essentially just, you can imagine like this network diagram with you have a table on top, and you have like the node below and a node below and a node below. And this didn't really scale because for everything, you need to define the whole system again and again and again. And so that's kind of like where some brilliant people came up with a relational model where you can actually just like define more declaratively what you want instead of like having to always kind of like specify exactly how things should work. And interestingly enough, it was about 10 years after relational model was invented that SQL was actually invented. And it was invented by different people than relational model, even though most people actually associate SQL only with relational model. And the kind of genius of the SQL language is that it takes a lot of like set theory. So myself, and I'm assuming a lot of you are not experts in set theory. And the reason why we don't need to use set theory, which kind of like is the foundation of relational model and SQL, is because we have these great abstractions. And SQL has gone through a lot of changes over the years where it used to just be kind of like SQL predates the internet. And so you can imagine like how much development there has been going on. And over the years, kind of SQL has gotten standardized in what's called ANSI SQL. And that kind of specifies kind of the general accepted best practice for SQL. But if you know a lot of databases and have tried a lot of databases, you'll know that nobody does ANSI SQL. There is always differences. Like Postgres has its own kind of like SQL. MySQL has its own SQL. And if you want to transition from Postgres to MySQL, like you can't just run the same query. So yes, there is ANSI SQL, but nobody actually adheres to it 100%. There is always customizations that you do for your own database, and there's always kind of ways you want to look at things. Now, we know that with NoSQL databases like Mongo or graph databases like Neo4j, they have their own kind of like custom query language. And those are kind of often thought about as NoSQL. But the interesting part is that NoSQL was actually thought of first with a relational model. And so this is actually, even though SQL is very much connected to the relational model, it is just an abstraction layer over kind of like how you query your data. And it's an abstraction that has been very persistent. People have stuck with SQL over the past 50 years. So while there has been a lot of development in like programming languages, like we don't use COBOL anymore. Now, COBOL was basically the first language that Postgres was written in. Or actually, it was written first in Lisp, and then you had COBOL querying, and then you had SQL. Now, we don't really use COBOL much anymore as a programming language. We have kind of like higher abstractions. But SQL has been a very persistent, and has been like an abstraction that we have stuck with very much. But with SerialQL, there are a lot of problems that we kind of like solve with the SQL. One of the big ones is kind of like composability. Now, SQL in general is not very kind of like developer friendly in many ways, even though it's very easy to understand. But it might be good then to hear from you, Toby, about like some of these kind of decisions of like when you were looking for the different databases and kind of like designing it from the beginning. Why did you kind of decide to go for the SQL-like approach?
Yeah, it's a great question, and it's interesting, isn't it? Because you said at the beginning, you know, people often kind of correlate SQL with relational, and it's not that at all. You know, SQL, you're seeing that more with other databases out there at the moment, but SQL is a language that enables you to work more easily with set-based data or collections of data, whether that is on top of a graph database, a time series database, a document database, or a relational database. And often, you know, people say, oh, you know, SQL or no SQL. Well, it's interesting. It's really relational or non-relational. Obviously, SerialDB being a non-relational database, but with an SQL query language. And Yeah, I mean, over the years, me and my brother, before we kind of created SerialDB, we were using many different databases, many different languages, as you say, MySQL, query language, and Postgres, and we use RethinkDB as well, which had a very complex, very advanced and complicated query language called ReQL, very powerful. But I think at the end of the day, developers always want to turn back to, or they want to have the ability to do both. They want to be able to perform CRUD operations and work directly with some kind of ORM or API, but at the same time, there's nothing really out there that kind of beats working with vast collections of data and analyzing those and grouping that data together very well compared to an SQL language. And I think that's why we decided that for SerialDB there had to be a query language that was close, if not very similar to SerialQL. Traditional SQL. Albeit there are differences in this functionality of SerialDB, and therefore, in our opinion, we had to go slightly away from the traditional standard. And so that's where you see kind of SerialQL today. We've got some great bigger plans, as you saw, and if any of you might have seen in the last beta 9. There are a lot of new functionality added in around imperative code blocks, and I know Alexandra and Misha want to talk about that code blocks today, and just kind of the power of that and what you can do and what flexibility that brings to your own applications. But also other features that have been in from the launch of SerialDB, including the relate command, which enables you to operate on your data in a graph-like manner, comparatively with what are effectively record links, otherwise known as kind of foreign keys in other databases. So yeah, it's for us, to answer your question, Alex, it was a no-brainer to use SQL. For people who have a good understanding of code, or for people who come from the data science side of things and have no real concept of code or how data is stored, but want to query that in a very simple yet advanced and powerful way. I don't think there's anything better than SQL, albeit we needed to add the Serial touch to it, so that's what we did. And we've got some big plans, so lots of changes coming. But yeah, if you want to just carry on and maybe dive into some of the more advanced features of SerialQL and what that leads to.
Yeah, I'll share my screen and we'll go through some SerialQL. We'll start off relatively easy, and then we'll kind of like go more progressively more kind of like complicated, because the power of SerialQL is that it is very simple to use and simple to learn, but it is also incredibly powerful. But the great thing is that you kind of don't need to kind of jump straight into all the kind of like learn a completely new thing if you just want to do simple things. So what do we mean by like SQL? So part of the ANSI SQL is kind of like the syntax, select star from, say, a person table. So this is kind of like everybody agrees that it should be a thing. Now, there are a lot of kind of like cool things for SerialQL that we have implemented. One of them being the way we do IDs. The way we do IDs is that we essentially have two strings. So you have the table, and you also have a colon, and then, so for example, we could have a shirt. So this could be an ID. And you notice that I put it after the from statement. And what this effectively does, just like you would be selecting a JSON ID, is that you don't actually have to kind of like do a full table scan of something. You can just like literally say, hey, I just want one ID, and that makes it like super efficient. Now, this is not ANSI SQL, and this is something that you really don't find in other places. But it is super useful and kind of super powerful for what if you were like doing things in real life. And even if you want to just kind of like do things very simple, you could do something like a return. where you just get this one record. This again is not ANSI SQL, but it's also kind of like going more into different concepts. But then you have things when it comes to, say, composability, because oftentimes you have SQL and you have things on top of SQL. So you have like ORMs, which are like object relational mappings. You use like it with JavaScript. You use it with like a templating language. So for example, a company used to work with DBT Labs. They are very heavy on SQL because for analytics people, it's very easy to learn SQL. Like you're not necessarily going to learn the ins and outs of like a lot of backend languages, but SQL is kind of approachable for people. But when you're sticking with ANSI SQL, you have these limitations. So you need to bring in extra stuff. And so you bring in a templating language, or you bring in a lot of different things. So the popular thing there is using Jinja syntax, which adds a lot of like curly brackets everywhere in your code. But what if we could actually just do this kind of composability right in SQL? So here we essentially have a normal kind of like subquery. But what if you can actually assign that subquery to a value? So we have here the value sales that includes this subquery. And now we can actually work with this value. So we can have another value here, total, and we can do some more stuff with it. We want to kind of like say the total sales. And here we actually want to count the sales, and we want to do essentially the average sales. Now, you could just do this by itself. That's no problem. But then it kind of gets increasingly more advanced, where you want to maybe essentially define in analytics term like a semantic layer, or you want to define like metrics across your app. So if you're using a lot of people using the app, you don't want to define average sales like all across your application. You want to kind of like define it once so like everybody can use it. And this is like a way you can actually do that very simply. But it gets even better than this. So if you notice the return statement here, now what the return statement does is that it allows us to run all of this code in this kind of like code block. If you notice the curly brackets, it allows us to run all these statements, but these statements are actually not kind of executed to the user. What the user really sees is in this return statement. So this enables us to do a lot of kind of like stuff you would typically do in JavaScript or in Python or in other different ways directly in a database in a way that is much easier for a lot of people to approach and actually do. So this is definitely one example I wanted to show here. And then let me just go to, so let me just go to Misha now to see, you want to show another example of relationships. Misha, do you want to?
Yeah, let's see. Right. So essentially, so we've seen a lot of questions come by. What's the advantage to using record links or to using graph edges, right? So we got a little concept where we can show off both, how both would work, and why the one might be better than the other in a certain scenario. But really, it's a complex question because it's different per scenario that you're using them in. So for this example, let's imagine 3 persons here. We got Sobi, James, and Lizzie. And for the first strategy, we're gonna show off record links. So we'll update the person Toby, and we'll say that he is following James and Lizzie. How would we select the data? Well, to see who Toby is following, that's pretty easy. We can select who Toby is following, and we'll nicely get back an array with James and Lizzie. Now to see what people are following Lizzie, for example, so that's the other way around, right? It's a little bit more complex. See, we need to select the ID from the person where following contains person Lizzie. The issue with this is that we need to do a full table scan. We need to go across all the records, and we need to see if they match the where clause, right? So it works, but it's more of an expensive operation, which you don't need to do. So essentially, record links are really nice for one-way relationships, not for going back to that relationship too. That's where the graph edges come in, or so the relate statements. So let's say that we relate Toby in a way that he's following Jane, and then he's following Lizzie. How would we select the data back? Essentially, so this might be a little bit scary for seeing this the first time, but the way that I like to see it is that it's sometimes easier to read it backwards. So we want to select all the people that Toby is following, right? So essentially, what you need to imagine is that we grab Toby here, and this is essentially how it would look. So select everyone that Toby is following. It might look a little bit more complex at first, but when doing that query backwards to see what people are following Lizzie is a lot easier. It's the same result, but it's a lot faster and it's a lot more efficient. So yeah.
Yeah, thanks for that, Misha. I thought I'd just take a step back actually and kind of talk about those record IDs, because even though they seem quite simple in that, the concept is it's a table with an ID and the record ID itself. They are really the fundamental piece of Surreal QL that makes it so powerful. It is those record IDs that enable you to do single record CRUD updates or reads. They enable you to do time series based ranges or range queries. They enable you to do graph, and they really are the kind of fundamental, powerful building block of the entire query language and the entire database. And that was one of the biggest reasons why we didn't just kind of jump towards the traditional ANSI SQL standard of how things are done, because with record IDs, a developer is able to jump in and say, look, I'm building an ORM or an API. I want a specific record. I don't want to have to build a table index or query on a specific index. And as a developer, you can choose exactly how you store your data. Are you storing it based on time series data or graph data? How will you be querying it? How will you be reading it? And this is kind of, traditional methods that developers have to think about when it comes to column-based analytics databases or row-based databases. They have to make these decisions, but actually making those decisions within the query language themselves, so that you can have the power and the flexibility when it comes to high number of reads or high number of writes, or we're querying data in this sharding in this particular way that is similar to sharding, but at the same time, as a developer, you don't want to have to pre-think about how you shard your data so that it can scale. Effectively, as a developer, you want to build your application. And these IDs, these record IDs, enable you to do that. I know Alexander probably has something to add on top of that. After that, we'll jump back into Misha's screen, and we'll kind of look at the value statement, because or the value clause, the keyword, which has been used quite a lot in those queries. For anybody who hasn't seen that yet, we'll explain that a little bit. But yeah, Alexander.
Yeah. So the question of how do you optimize SQL, or how do you optimize SQL queries often comes up. And the general advice is, of course, reduce the full table scans that you're doing, and also reduce the amount of joins, because the way SQL works is that it actually doesn't run from select and so forth and so forth. It actually first runs kind of from, and then it kind of like takes the tables and it joins them together and then filters and so forth. And so the question is like, how do I make sure that I'm only taking the data that I want to begin with? Because the smaller amount of data that you begin with, the faster your queries will run. And so with the record IDs and with kind of like selecting ranges, which is also a very, very cool thing, it kind of helps you to be more pinpointed in what you want, and helps you kind of to, whether you're doing kind of like data intensive stuff or whether you're doing just want to be very kind of like precision focused, it really helps you to know that you're actually doing something that is highly performant. Because a lot of times when people start SQL, they kind of like do some queries and not necessarily sure what are the performance of this, like doing a lot of like select stars from like huge tables. But if we make it like really simple and kind of like to the point with like having these kind of like proper tutorials, if we kind of like make this kind of like tutorials about like, hey, here is how you use record IDs, here is kind of like typical ways of doing things, then we actually make it a lot easier for people to kind of like fall into the pit of success. So that like you just learn from the beginning, like, okay, here is how to make a good SQL query. And these kind of like record IDs help you to kind of like optimize that very, very simply.
Yeah, no, and I'll just add in there as well. Tutorials are definitely something we're going to be increasing or improving on. I think as a whole, though, we're looking at over the next couple of months getting example demo data sets that you as a developer can use, can test. Whether that's for testing out queries or for testing out benchmarking. And that leads us to another important point, which is benchmarking. And against these example data sets, both custom and ones that are traditionally used in benchmarking, we're going to be running SerilDB against those when we get closer to a version 1, and using those across all of our documentation, our tutorials, our playground, our dashboard, so that you can, as a developer, really simply get going with SerilQL from the basics to the really advanced functionality, some of which we're touching on today. So that brings us back to Misha's screen, where we'll jump in a little bit more, talking about that relate statement. I know Alexander's got a few things to say about that too, but also specifically looking at the value keyword, and potentially looking at the return statement as well. So in this example here, you can see on Misha's screen, we're actually composing two different queries. We've got a return query and a select query. And the select query itself uses a value keyword, which is found in other SQL databases as well. So I think if we could just jump in and explain what exactly is going on in that query, and kind of what happens if you potentially don't use all those, or if you wanted to select multiple fields, for instance.
Let's see. Yeah, there we go. So so essentially, what the return statement does is, let's see how to explain this. So for example, we are selecting ID and a name from a person, right? We'll get back an array, and every array will have an object. And let's say that is person Toby. We have name Toby, and the same for Jame, for example. So we have Jame and we have Jame, right? So what would happen if we use the value keyword and we wanted to select only the name? What would happen there is that instead of this whole object, we will be getting back just the names as an array. All right, so that's the first bit of the explanation. Now the second bit, let's say that we are selecting just Toby, right? So we're selecting Toby, we'll get back only Toby. And the magic of the return statement in combination with selecting just a single record is that you will suddenly not get an array, but you'll get just a string Toby. Let's see. There we go.
Excellent. So that's great. That really explains that that value clause. So effectively, I think the value was actually a recommendation from a community member who said, look, can we instead of pulling out an object with just one key, can we actually just pull out an array of those values? Especially that's really important when you're looking at grouping by and ordering by specific fields, and you just want that one field pulled out. So that was a great request from the community, which we really decided to was important and we wanted to build in. So again, just jumping back to our community, any suggestion, any idea that you think is going to be great in SurrealDB or you want to see in SurrealDB, we're always open to ideas, suggestions, issues. If you can, bug fixes and improvements to our code as well. Always open to that. Alexander, do you want to kind of talk about, I guess, our API connectors? Because although SurrealQL is very powerful, and I think another aspect we haven't touched on is the ability to run SurrealQL directly from the client device. Obviously, we're going to have a stream dedicated to that in the future to do with authentication, permissions, and kind of running SurrealQL right from within the browser. But kind of touching upon, actually, if you don't want to use SurrealQL, or if you want to use it some of the time but not all of the time, what are the other ways of working with SurrealDB and querying SurrealDB, and kind of the differences that relates to, and the power that those bring in their own way?
Yeah, absolutely. So a lot of developers are kind of like not used to writing the raw SQL, because there is a huge tradition of kind of like increasing the abstraction layer, and you don't necessarily want to kind of like add an additional language that you have to learn and have to kind of like keep up with. So how do we kind of like make it simple for people to enjoy the kind of like power of SurrealDB with kind of like a more simple approach? So we have a lot of kind of like database drivers for a lot of main languages. So we have the Rust API that just came out. We have Python, Go, JavaScript, and we will be kind of expanding that more into kind of, say, JavaScript frameworks like React and Svelte and Ember.js and all these kinds of things. And it's more about kind of like meeting people where they are in terms of like having a more simple approach. So you don't necessarily need to understand SurrealQL to that extent. We have like more simple APIs in your native programming language that kind of like make more sense to you. And with those, you can have the kind of like power of just using methods or using functions or simple APIs while kind of interacting with the database. And this kind of also touches upon, could we have like an ORM for SurrealDB? And this is, I guess, also a bigger topic, and we're very open to kind of like submitting issues and people kind of like coming up with their own way of doing things. We have people that have created an ORM type thing, like a community-driven one. And there is a great question about this, especially since we don't do joins in typical way, and joins are kind of like a fundamental things of ORMs. And so we're really open to kind of like discussing that with the community of like how the best approach is. But with the kind of like APIs, we also have the HTTP API, and we have a WebSockets API for people to also work with and integrate and suggest things that are great, and then what people want to work on.
No, that's brilliant. That's brilliant. I just want to jump into answer some of the community questions here as we go along, because there have been some questions regarding what we've been talking about today. So the first one is, can values be based on a unique group? So basing it on 2 or more columns. I guess this is a whole different topic that we haven't even touched on today. We thought we were going to fit in a SerealQL stream in just half an hour, but that's obviously, we're going to have to spread this over many weeks. We haven't talked about running SerealQL from the browser, as I mentioned before. We haven't talked about nested objects, nested arrays. We've briefly touched on record links and the difference between record links and full-on graph edges. But there's so much more to SerealQL that we haven't touched on. JSON, you can store data in embedded arrays, embedded objects, or embedded arrays of objects. You can structure your data as much as you want, but you still have the power to query that using the traditional SQL language. So unlike other relational databases that typically now have JSON columns, and querying that JSON column is kind of not exactly the best experience, in SerealDB, it doesn't matter how deep your nested array or nested object is, or even whether that object itself sits on another table, another record. You can join all of those records together as if that data sits right within each other in that record itself. So I guess that's a topic for another day. Looking at kind of how does JSON, how does embedded objects and embedded arrays work within Surreal. So that's a really good question, and something we'll touch on more. Kozgan answered. Regarding performance, have you already run some basic benchmarks? At the moment, getting up to our version 1, we haven't been focusing on benchmarks just yet. There are some big improvements to be made. The main one is based around the use of indexes. We've got another stream planned for talking about indexing, or specifically just indexing. So looking at traditional indexes, full text search indexes, geospatial indexes, and then the most popular one at the moment, which is indexes of vector embeddings, which we'll be talking about in a future stream. But definitely towards our version 1, we'll be looking at doing big performance benchmarking for like-to-like features with other databases, but also for features that you don't really see or can't really do in other databases. So that's really important. Alex, do you want to kind of jump in on anything there? Because I know that's your area of interest, and yeah.
Yeah, absolutely. It is kind of like surreal how much you can do in SerealDB, and like in my previous life as a consultant, you have this kind of situation where a company starts with a database, typically a relational database, and then they get a request, and they're like, okay, let me add this in there, and then you kind of get this kind of like increasingly more complicated requests, and because like things keep evolving, like people say like, oh, it would be great if we could like have an embedded version of this, or we want to run this on the edge, or actually we want to kind of like scale this up to like 1 million people or like more, and then you have this kind of like, as the business gets more successful, you have more use cases, and that's kind of like can either increase the complexity a lot, where you have to like learn new languages, you have to learn new ways of thinking, you have to kind of like go through all of these things. But what if you could actually just kind of instead of going through a long procurement process, going through a long learning process, going through all these kinds of things, when you get a request and say like, hey, it would be great if we could actually show some like network stuff, because people like network stuff, that you could say, yeah, we already have that available, and like just like putting that out, versus having to kind of like go through a process of searching for stuff, go through a process of like doing a POC, go through a process of integration, go through like all these kinds of things. So having all this functionality, even though you don't necessarily use it today, having the option to kind of just like quickly try something out, or like you have a request and you say like, okay, it would be great if we had this one feature here or one feature there. I'm really excited about like these kind of use cases for SerealDB, where it kind of like raises a ceiling for what you can easily do. So instead of doing some crazy hacks and workarounds and kind of like things that I've historically done in consulting that like nobody would ever want to touch again, because you would have to kind of like break the tool, because you can't wait for this kind of like months-long process of like getting the right tool. And so that's kind of like excites me about SerialDB, is that you have all this power available to you when you need it.
Yes, that's really interesting. And I think it's really important for us just to add, benchmarking is very important to you as a community. It's very important to us. And, we're not going to be shying away from that in any way. We're going to be doing that and benchmarking in as many different ways as possible. Obviously, that's quite tricky with regards to SerialQL and SerialDB, because there are so many different ways that are, that can compare with many different types of databases and different use cases, from the front end to the back end to the traditional database tech stack to the time series based database, which is specialized in just storing time series based data, to graph database engines. But that's definitely something we're going to be doing and focusing on, so that you as a user, as a community, have a really good, thorough understanding of how SerialDB performs and where it kind of outperforms the rest. Another area I've just realised as I look through these questions. So Osario asked at the very beginning, kind of, would love to see the entity definitions behind the queries, and that's something we will have to touch on in another future stream, because there's now new functionality which is coming in the next release that works with stricter typings, so that as a developer you understand that the data that goes in the database always is of a certain type and can never just be converted to another type without your kind of understanding that it's doing that, and then defining again entities and tables and embedded objects and embedded arrays we'll look more closely at in a future stream, and also be improving our documentation so that it's even easier to get going with SerialQL. But there are some great questions here I haven't touched on. I'll try and touch on a few more. Just to add, we're going to jump onto our Discord community after this stream for a question and answer session where you can effectively ask anything within reason, and we'll try and answer as much as we can. We'll whether that's helping out with some code, or talking about features, or talking about what's coming, or talking about any of the things we've discussed today. So we'll be doing that shortly. I just want to highlight one comment here from Alciwan. Never want to touch a join again. That's exactly why we built SerialDB. We don't like joins, especially when those joins go at any more than just one table to another table. So SerialDB, the aim is to never have to work with a join again. So if you're not using SerialDB already, then definitely give it a go, try it out. Another interesting question earlier on from Matthew. It's a great question. I think you've answered it before elsewhere. I'll try and answer it today without giving too much away, albeit I probably just gave too much away. But yeah, we've got some big plans for SerialDB. Obviously, the ability to run in WebAssembly is an important part for us for running in the browser. And albeit we can't talk too much about what exactly those plans are just yet, we've got some big plans for running SerialDB in as many different scenarios and use cases as possible, whilst at the same time keeping it performant and working as you would expect as a developer. Making sure your data is consistent and ACID compliant and durable and everything else that as a developer you would want, rather than having to work that out in your own application code. So I guess there's so much that we haven't discussed today, that we'll have to discuss and move to a future stream. I guess Alexander, Misha, especially Misha actually, because you came from our community looking for a database that you could use in your projects, and I think I don't want to put words in your mouth, but did you fall in love with SerialQL? I guess I kind of did.
Yeah.
I guess, what was the thing that really shone or stood out to you, that changed your mind on why you should try SurrealDB at its early stage, because we're not yet at a production ready release just yet. So what was that one thing?
So it's not really a one thing, but I can describe it in one concept, and it's just that it's the combination of the power that the SurrealDB query language gives you, and at the same time staying that flexible. That really impresses me, and that sold me. So been using it ever since.
Excellent. And Alexander, you've used many databases over the years, I know that, and not just from a database perspective, but also from a data science perspective. So I guess I'll ask you, unless you've got anything else to add as well that I've missed, but I guess I'll ask that question to you again. What is that one feature that kind of piqued your interest in SurrealDB in the very first time you saw it?
I think the first thing that really piqued my interest was actually the record IDs, because that just kind of like makes things so much simpler. Both that and like the way kind of like of handling the join complexity without actually having to kind of like push that to the user. So I'm like a big believer in like making smart software that kind of like makes complicated things simple, and kind of like looking over the SurrealQL and kind of like seeing with a kind of like understanding of like, hey, here is how you do performance SQL and like all this kind of stuff. It's kind of just, it really kind of shown through that like there's a lot of thought put into kind of like, hey, how can I make this as enjoyable experience as possible? And that kind of enjoyable experience is really important when you're working with databases day in, day out. And so, yeah, I just like things that are well designed, and that kind of like really spoke to me.
That's great. Thank you for that. I guess, before we sign off and jump onto Discord for a question and answer session, I guess I just want to say to the community, this is our second stream in this format, pushing it out to LinkedIn and YouTube and Twitch and Twitter. And we're always up and open for comments, suggestions, improvements. It was actually the community who said, look, please bring us a stream onto Discord. So we're doing that today. But again, if you've got any suggestions, whether it's about the stream, whether it's about the code, features, SurrealQL, definitely jump onto GitHub, add an issue, a bug request, a feature request, jump onto our Discord as well, not only for the question and answer session now, but going forward for support from our team and from the community. We've got a very vibrant, very excellent community that without that community, SurrealDB wouldn't be what it is today. So I just want to say, Misha, Alexander, thank you very much for today. I think we've learned a lot, and especially that we need to do a few other sessions on SurrealQL and some of the features that we haven't touched on. We haven't even touched on custom functions and global parameters. There's so much typings that's coming in a future release. So we'll be doing another few streams around SurrealQL in the future. Again, some other streams to look out for in the future to do with indexing, authentication, deployment, and everything else in between. So we'll look forward to seeing you again in the future. But for now, we'll be jumping off here and jumping onto Discord for question and answers. See you later.
See you.